In this lesson video, we will first introduce index on algebraic variable or expression, and then we will see how defined index or power works on negative sign. Then we will describe index law 1, that is multiplication of two same base terms, and index law 2, division of two same base terms with some examples. Here we will learn the use of index form in algebra. When same number are multiplied several times, we can represent that number using index form. So for example, here 2 times 2 4, 4 times 2 is 8, 8 times 2 is 16, so that means 16 equals this, and we can represent it like 2 to the power 4. That means 2 is multiplied 4 times. So this is for value. So we can use this index form in algebraic calculation also. So for example, if a variable x is multiplied 3 times, then we can write x to the power 3. That means here the same variable or pronumeral x is multiplied 3 times, so x to the power 3. If another pronumeral, say a, is multiplied 5 times, we can write a to the power 5. In generally, if a pronumeral x is multiplied, say there are n times, so same pronumerals is multiplied n times, so instead of writing all n like 5 times, like 3 times, all n times is x as multiplied, in index form we can write x to the power n. Here the variable that is multiplied several times, this part is called the base. In index form, this same variable that is multiplied several times, that variable is called base. For example, in number index form, here this 2 is multiplied several times, 4 times, so here this 2 is base. Here x is multiplied 3 times, so x is base. A is multiplied 5 times, so a is base. And the number of times that same base is multiplied, that comes as index or power. Index, we called it index or power. That means x to the power 3 means x is multiplied 3 times. A to the power 5 means a is multiplied 5 times. So similarly, if we write y to the power 7, that means this is the index form. Here base is y, power is 7. That means y is multiplied 3, 4, 5, 6, 7. So writing this multiplication form takes time and space. So in index form we can shortly write that y is multiplied 7 times, so y to the power 7. Say z is multiplied 100 times. That means what? We need to write z multiplied z in this way 100 times. So using index form in algebra help us writing in precise form, the small form, when we need to write lots of multiplication of the same base. So in general form, the general form of index term is algebraic term is x to the power n. That means where x is the base and n is index or power, and x to the power n means the base is multiplied with itself n times. Now we will see the effect of index on negative numbers or negative pronumerals. So for example, minus x to the power 1. That means here minus x is the base, because whatever is the base and power is on top of that. So if we take minus x to the power 1, this means minus x is multiplied only once. If we take minus x to the power 2, that means here base is minus x and power is 2, then that means we know that base to the power means the base is multiplied with itself, and the number of time it will be multiplied with by itself will determined by this power. So here the base is not x but minus x. So this whole minus x is the base and power is 2. That means this base is multiplied with itself 2 times. That means minus x times minus x, and we know minus minus gives us plus x square. Again, if we take minus x to the power 3, that means here base is minus x, power is 3. That means this minus x base is multiplied with itself how many times? 3 times. So minus x times minus x times minus x. This will give us minus times minus is plus, plus times minus is minus, and x to the power x times x times x is x to the power cube. So if we take minus x to the power 4, then base is minus x, power is 4. That means minus x will be multiplied with itself 4 times. So minus x times minus x times minus x times minus x. So now minus minus plus, plus and minus minus, minus and minus plus. So at the end of the day we will get plus and then x times x times x times x. This can be written in the exponential form as x to the power 4 because 4x are multiplied, so x to the power 4. So if we see carefully that minus x, that is a negative variable, power is 1, then it becomes minus and that power. When minus x, that is a negative variable, power is 2, it's becoming plus and that power 2. Minus x 3, then it's become minus and then power 3. Minus x to the power 4, it becomes plus x to the power 4. So if the power on a negative variable, if the power is 1, 3, that means odd. These powers are actually odd value. Then we got that power but minus. That means we can write, in general we can write that on a negative variable, if we have an odd power, odd means 1, 3, 5, 7, this kinds of odd value as the power, then we can directly write that minus then x to the power odd. That means we can bring this minus out of the power index. So it will be minus x to the power odd. Here this power in this form, this odd power is both on minus and x, and here minus x to the power odd means, that means this power is only on x. For example, here minus x3, this power 3 is both on minus and x, but here minus in front and then x to the power 3, that means this power is only on x. So when a negative variable will have odd power like 1, 3, 5, 7, 9, etc., then we can bring out this minus and the power will be on the only on the variable part. And here if we see even, that means when power is even like 2, 4, 6, then we are getting minus x to the power even is giving us plus x to the power even. That means if minus x to the power 2, we are getting plus x to the power 2, minus x to the power 4, we are getting plus x to the power 4. That means any even power on a negative variable, even means 2, 4, 6, 8, then this minus will become plus and the pronumeral, the variable, will get that even power, like here x2 is plus x square, minus x to the power 4 is giving us plus x to the power 4. So in this way we can handle the negative sign in index form number. Now we will do 4 examples based on the concept we learned about algebraic index form. So here x to the power, so we need to find out what is the value here, equals this. So here the base is x, we know the base is x, And now we need to count that how many times x is multiplied with itself. So if we count 1, 2, 3, 4, 5, that means x is multiplied with itself 5 times. So the power will be 5. So this blank space will be 5. So x to the power 5 means x is multiplied with itself 5 times. So here x is base and 5 is power. That is not given. So the answer will be 5. Here 1 by x to the power something equals 1 by x times 1 by x times 1 by x. So here x is not base, but 1 by x is being multiplied with itself how many times? 3 times. So that means here the base is 1 by x and it is multiplied 3 times. So it will be base to the power. We know the index form is base to the power index. That means base will remain down and index is on top. So here 1 by x is the base. How many times it is been multiplied with itself? 3 times. So that means the power will be 3. So 1 to the power x3 is 1 to the power x times 1 to the power x times 1 to the power x. So for example, in this example, x is being multiplied with itself how many times? 4 times. So here this 4 is given. That means the power or index is given already, but the base is not given. But we know from here that what is the base? X is multiplied with itself 4 times. So x is the base. So we will write here x. X is the base. So this is the base. That means in this problem, base is given, power is not given. And here power is given, base is not given. And from here we can see that the base is x. So it will be x to the power 4. In this problem, x to the power 3 is being multiplied with itself how many times? 4 times. So power is given 4, base is not given. So what will be this base? Base will be x by 3. So this one will be x by 3 to the power 4. So the blank space will be x by 3 actually. Okay. So in this way, if we are given power, then base, then we can determine the power. Or if we are given power, then based on this right side expression, we can determine the base.